Hey, you guys are going to get a note that the class is being recorded tonight. I don't actually know what happens if you don't push OK. But we have a student in the hospital, so. Okay, how's everyone doing? I'm just pulling up what I need for tonight. We have lots to go over. Okay, so tonight we are going to go over chapter 13, which is two-way ANOVA. And then I'm going to actually, this is a really good week to start our review for the finals. So for those that want to stick around, I'm going to go through how, well, I'm going to tell you now how the final is going to be set up in exam 3. And then I'm going to go back to chapter 9 and start to review a little bit so that next week is jam-packed. We do correlation and regression in 1 week. And then the week after that is chi-square, and then our review, and then our final. So it's only 4 weeks left, and then you guys are done with the course, which I'm sure some of you are very excited about. As far as exam 2 is concerned, we have had a problem with it. A copy of it wound up on a site called Chegg, which I'm sure you guys are familiar, and the wrong answers were given by the Chegg service. So I would be very careful if you're using Chegg for any of your classes. I've been in consult with the dean about what to do about it. I have to submit some work to her tomorrow morning, and I'll be releasing your grades by the end of the day. So that's exam 2. Exam 3, I've put a spot for it already in our course. It's going to open on Friday the 28th, and it will close May 2nd as our class is starting. So it's Friday to Tuesday at 6. It is going to be completely SPSS. What we're going to be doing the next few weeks, especially, well, tonight, but also next week, and actually, yeah, the next 3 sections are incredibly detailed when it comes to the technical aspects of the math, and I don't want you to get lost in that. So exam 3 is going to be, let's see, I counted them, I wrote them all out today, 1, 2, 3, 4, 5, 6. It's going to be 6 very quick SPSS problems for you to complete. So run the SPSS analysis and then answer a couple questions. That's it. It will serve as the review packet for the final. So when you guys finish it on May 2nd, we come into class, and the only thing that's not going to be in there is chi-square. So it will be, the final itself goes from one sample t-test right through chi-square at the end of the semester. The final exam will be only a packet of SPSS printouts and some context about what the problems were about. Almost no calculations that I really foresee. It's going to be all, here's the data. It's not even going to give you the data. Well, I could give you the data. I really haven't decided with a couple of them yet, but it's data, context, data, printout, interpret. Very easy if you've been paying attention. You will, for the exam, this is the final. You will log in here with me on that Tuesday night. Now, some of you have accommodations. It is a 2-hour exam. I will be here for a total of 5 hours. Obviously, I won't be in front of my computer for 5 hours. I will have to mosey around a little bit. But I will be here open for 5 hours from 5 until 10 on Tuesday. Shoot, I just had the date in my head. What is it, the 6th? Is it up here? The 9th. Tuesday the 9th. You will log in, go on a web locker so that you can't look anything up, but you can have anything in front of you that you need. If you've been keeping up with the class, with the homework, with SPSS, with everything that I go over every week and interpretation, you will be 100% fine. I actually just recommend printing everything out, making sure that you can run it so that you don't get jammed up with the review, because it counts as that 3rd exam. And then you'll just, again, it'll be a series of printouts. Where is my water? Here it is. So that's it. All homework must be submitted by the time the final exam starts on the 6th. And unless you are in a grave situation, there will be no makeups for the final. So I don't have a lot of wiggle room in giving a final at that level with the 5-hour window in person with me before grades have to be submitted. That's why I'm using the last class. Does anybody have any questions about any of that? No? None? Nothing? Okay. Hold on, I'm responding to some private messages here. Okay. So let's see. Let me share my screen. So this is 13. Okay. So 13 is a factorial ANOVA. So last week we did an ANOVA where we were comparing 3 groups. Remember, we use ANOVA because doing all the individual t-tests will drive up the error rate. That's really, really important to know. This week, we get into what happens if you have more than 2 groups or if you have more than 2 variables. I love at this point in the semester when students go, oh my God, there's more to this. And yes, there is. You can blow out ANOVA tables to 2x2s and 3x3s and 4x4s, and they can just keep growing. So just know that this does not end here. These are the foundational pieces of what we do for bigger ANOVAs in the future. Honestly, even if you go into like higher levels of stats and psych, and then even through grad school, they really don't get much more complex than maybe a 3x3 table. So we will learn what the effects are. We'll talk a lot about cell means. Cells become important. We use Fs in the 2-way ANOVA, just like we did with the 1-way. We'll learn about significant effects. The big learning part here is main effects and how they work, and then interactions and how they work. That's the new word. Just want to make sure that we're still recording. We actually, you know what? I'm going to take this out. We're not going to, I'll leave it in. I'll see what happens if we want to do it. Okay. So analysis of variance, as we learned last week, analysis of variance is when we have more than two groups. So you can use a t-test for two groups. You can actually use an ANOVA for two groups as well. But once you get more than two groups, you definitely want to run an ANOVA. With the ANOVA that we saw last week, we might have one grouping variable and one independent variable. And now we use what's called a factorial design, which is more than two treatment groups. This is the basic ANOVA. What we do is we have two factors, factors A and factors B. We try to keep this simplest at first. Okay, so we talk about cell means here. You can see this X bar A1, B1. That is the mean of cell 1 for level A1, level B1. This is the cell mean for this cell. A2, so they got 2 pills. B1, still 10-year-olds. And then we just move down to the other 2 cells. These are now 20-year-olds. We want to know, how do 20-year-olds react with 1 pill versus 2 pills? We can, at this point, also look to see just how does the 10-year-olds do? How do the 20-year-olds do? And we can look to see how 1 pill does versus 2 pills. So there's a lot of comparisons that can go on. When we use the ANOVA test, all of that error rate is kept down, which is awesome. Just for clarification, in case anyone's like, oh my gosh, I'm freaking out, all of these X's are individual scores that were in this cell. And I think that's about it. Let me go back. Let me show you very quickly, just so you understand. When we go to compare all of this, the ANOVA table looks like this now. So we have between sum of squares is broken out now into 3 factors. We have the one on top, the one on the side, and then the interaction. How do they interact with each other? And then we still have within and total. So for this particular situation where we have the 4 cells, 2 by 2, we have 3 different Fs. 1, 2, or 3 can be significant, or none of them can be significant. So one can be, so you can have a significant A and a significant interaction, but B is not significant. There's no rhyme or reason or rule about what is and what is not significant. Okay. Where was I? Okay, so that all of these numbers turn into some pretty detailed, heavy math, which your book loves to go over, and I hate to go over in this course, so we don't do it because you guys just don't want you focused too heavily on the math. I want you focused on the interpretation. Now, what happens is this is called combining levels. We are evaluating whether this level, the 10-year-olds, react differently with 1 pill or 2 pills. We are evaluating level A. Does how do the 10-year-olds compare to the 20-year-olds? So that's the other factor. These are called factors. Factor A here is number of pills. Factor B is age. So each combination we have cells, and then the main effects is when we ignore the other. So this is a factor number of pills. It's also the main effect would be pills. Is there a difference? This is the factor B is age. We look to see if this main effect would cause a difference. And then the interactions, what happens when the cells combine? So when you are talking about interactions, and I'll show you in a little bit how we graph them and how we talk about them, but it's like, how does the interaction, how does the particular treatment change over your levels? So is there an actual difference? Do the pills work the same on a 10-year-old and a 20-year-old, or are they different over the 2 ages? Treatment. We talk about cells and cell means. I went over that. There's no effect. Okay, so let's look at some examples that I left for you guys in class notes. Let me download this quickly. See if I can turn it here. So this is why I don't do the math, because this is a nightmare. So this is a two-way ANOVA table. Some of this, if you've kept up with class for last week, from last week, some of this will look familiar. So every ANOVA table has a source of variation. Essentially, what are you comparing? What are your main effects? What are your treatments? So this is treatment 1, this is treatment 2, and then this is the interaction. I say sum of squares here is given because it's a nightmare to calculate. So it will be given to you. SPSS calculates it for you, so you don't have to worry about it. And then the degrees of freedom, you have to be careful. Why are degrees of freedom important here? Because you have to understand where the critical values come from in the t-table. So if you understand p-value, you're in good shape. But remember, we also have to understand where they come from in the F table. Now, this mean square column is the exact same thing that we had from mean square in the one-way ANOVA table. It's just your sum of squares divided by your degrees of freedom. Oh, and let me just tell you this because I didn't include the chart here. A minus 1 is the number of levels of A minus 1. B minus 1 is the number of levels of B minus 1. So then you just multiply A minus 1 times B minus 1 for the sum of squares for the interaction. For tonight's purposes, these are all going to be 1. And then big N here is the total number of subjects in your experiment. And then you can just see the math and how that works out. But again, it's all given to you in the SPSS tables. Now you have 3 F terms. And this is, remember, you got, like, what do I always say? You got to keep your wits about you. You got to stay organized. This is your mean square of A divided by your mean square within. So your mean square within is your error term right here, same as last week. This within, what is your error term within each of your groups? And then I also, on the side here, even though it's right being written up the side, I wrote how to look up the degrees of freedom in the F table. These are the degrees of freedom that you would look it up with. Let me just, oops. Okay. Right here. So I think I'm going to need to turn this again. Now, what I want to talk to you a little bit about now, because the big piece of ANOVA is the interactions. So this is another page in the printout that I've left for you. These all, and you can see it's kind of messy because all I wanted to do is fit it on one page, so it's super easy. When you have any set of cell means, so where were we? We were here. So pretend that that we have one mean for each cell. You can graph them and see if there is an interaction. Now, we still don't really know if that interaction is significant, but even if it's not significant, we can still talk about it. So if you graph each of the cell means, you will get a graph that shows you what's going on. Now, in this one here, we have one, and it's going to be clearer on, maybe I can enlarge. I don't really like to fiddle with this when I'm live. So maybe that's a little clearer. So here we have one straight line. So A1 and B1, there's no difference between them. They function the exact same way. And this is an obvious example because every cell mean is the same. So here, A1 at B1 and A1 at B2, there's a little bit of variation, but there's only one line still. Here, in this third example, the lines are parallel. When you have parallel lines, there is no interaction. So if your lines are the same or your lines are parallel, there is no interaction. let me just see where I want to make sure I have a definition written out. Yep, okay. Now we get to interactions. So on the right-hand side is interactions. Now there's a few different types of interactions. There's a pure interaction, a disordinal interaction, and an ordinal interaction. And I have the definitions here. So anytime that you do not have perfectly straight parallel lines, something is going on. Now write in your notes, an interaction, you can have an interaction, but it might not be significant. You do not know if something is significant until you go through the steps of hypothesis testing. A pure interaction is when the two groups function and you have this evenness. A disordinal interaction is when it looks a little odd, like it doesn't look normal. There's a cross here, but there's a slip, and I have good examples also in the slides. And this is an ordinal interaction. So what this says is, while there's no actual cross here, it's not performed. Eventually they would cross. So the lines aren't parallel. The most important thing for you guys to know is that when the lines aren't parallel, there's an interaction. Whatever it is, treatment A or B does not function across the different levels of the other variable in a normal way. Something happens. And this kind of makes sense with just the basic examples that we've seen. A 10-year-old taking a pill is not going to have the same effect as a 20-year-old taking the same pill. That is why, you know me, I love the COVID example. That's why there's a different vaccine for children than there was for adults. And the kids one was released much later. Because kids and adults, our bodies don't react the same over time, or to different medication levels, or to medication in general. So they're going to react differently. So here, this is a little further in the slides, and I covered up some of the typing here. So with an ordinal interaction, there's changes in the levels. The lines don't cross, but one always seems to stay greater, but they lose parallelness in some way. This is when there's a switch. So here, you're graphing gender, male and female, and at some level of whatever, oh, this is socioeconomic status, there's a switch between male and female. It's like they're both dipping a little bit. Which one is it? Males dipping a little lower, and then males dip really low at high levels of socioeconomic status. What's the number of behavioral problems? So apparently, the wealthier you get, if you're a man, you kind of start up here with a lot of problems, but then you dip low and your problems go down. How stereotypical is that for an example? Okay, and then the disordinal, again, there's a switch. One dips below the other and there's a cross. Neither of these are pure. So again, you know, this is a great reference as you go on to other levels of statistics. This is a great reference for you to have in your other classes. Like, print this out if you're going to be a stat geek like me, or if you're even going to go on to higher levels of psychology. Like if you're going to be in that class that Cole and Sim have, you're going to really want to keep this close by, because the professors, right, Cole, they talk about this. Yeah, I know. So again, I just wanted to show you a couple of more examples of how this works. These are in here. So when you're going over your notes, these are group means. Now, I use this example later on in class. Here I use it in a different way, though. I just want to show you what happens with group means. So the setup of this is the numbers, the means is the mean number of word recall. You guys will learn, you're really young in your stat psychology career, you will learn that people, psychologists, love to test word recall. It's a function of memory, it's a function of intelligence, there's a lot that goes into it. So and we've seen examples like this throughout the semester. So this is how much sleep you've had. This is if you've had memory training or not. And then these are the average number of words that were recalled in every block. You can see just by eyeballing it, the more sleep you get, and if you have memory training, you will recall more words. This makes sense. Now we look at, and again, this is just to start to introduce the bigger concepts here. If we look at, these would be the means of the main effects. The main effect here that we're evaluating is memory training or no memory training. The mean of memory training appears to be higher. Again, this makes sense. And then these are the means of sleep. So the average person with no sleep, 4 hours of sleep, and 8 hours of sleep, these are the means of those groups. So this is a main effect of sleep. And we can see, obviously, that this goes up. The more sleep you have, the more words you recall. What does this look like on a graph? Right here. I have a note to myself to go to slide 5. I don't know why. No clue. Where was I? Okay, so here I graphed it for you. So there's no interaction, right? We don't see any difference. Like there's no dips, there's nothing. It's just as for the 2 lines, the memory training and no memory training, the more sleep you get, the more words you recall. But now we can also change those numbers. So now let's look at if here, memory training, no memory training, now our cell means are different. Our training means are actually now the same. Now we graph no memory training over and a line for memory training over the 4 hours of sleep, and we show an interaction. Something weird happens. Memory training winds up or starts out with a lot, and then by the time you're getting more sleep, the memory training people aren't answering as many word recalls. And the exact opposite is happening. If you have no memory training, you start answering when you have no sleep, few words, that kind of makes sense. And then no memory training, but a lot of sleep, the number goes up. And there's this cross here. So you could say things like no memory training and memory training is dependent on sleep, but the relationship flips at some point. The cross indicates a flip because the lines cross. Now, if we change them one more time, I didn't include this, but if we change them one more time, this would be that ordinal interaction. So the memory training line and the this should be no memory training. They don't cross, but they also don't stay consistent. So this is an interaction as well. At the end of the day, you can tell a lot from the graphs, but you always need to do an analysis. Okay. Let's look at the examples. So each cell, we saw that they contain means. Okay, so assumptions of a two-way ANOVA. Remember, we love assumptions. Every test has assumptions with it. Each cell of this kind of ANOVA contains all independent samples. So these guys in here are completely independent of these guys in here, or gals. And these are independent, or these are independent. So everybody was randomly selected, everybody was randomly assigned. There's no, people weren't matched, everybody's a different person. As always, in order to do an ANOVA, the dependent variable must be measured, it must be normally distributed, and it must be an interval or ratio scale. And the populations have to have homogeneity of variance. And remember, we can test for this. This means that the variance of each of the groups is equal. So we do the homogeneity of variance test again. This slide just talks about the main effects. So every main effect has it has its own set of descriptive statistics. It has its own mean, it has its own standard variance, and it has its own standard deviation. And what we can do is we can look at those main effects in and of themselves. So we can collapse the factors and look at the results of like one pill against two pills, or males, females, or ages, whatever we decide to do. Two-way interactions, that's what we're calling these. So when you have two factors and they're interacting, you have a two-way interaction. And when you look for the interaction effects, you're comparing all of the cell means, which kind of makes sense with what we saw over here. The interactions are based on cell means. But when we are looking at the main effects, then we're just looking at the level means. So it's really important to get this down. When you're looking at a main effect, like when you're looking, is there a difference between 10 and 20-year-olds? You're looking at the mean over here across both levels of A. So while I am militant on you learning interpretation, it's sort of important to tuck in the back of your mind where all this data is coming from. And I lay out the examples so that you really get used to seeing it. And then and again, I put these right out of the book just so that I could talk about them. So you had notes related directly to what was in the book. So again, this would be, this is actually a strong relationship. So the strength of relationship and mean self-esteem score. So strength of some relationship, I forget what it was in the book. And then news websites and Facebook browsing. And you can see that over time, over the levels of this relationship, whether it's weak or strong, news websites have give you a lower self-esteem than Facebook browsing. Now here on this one, something interesting happens because there's a cross. So news websites over strength of relationship stays constant, but the weak relationship starts out lower. And then for Facebook browsing, it crosses the line and it's now a stronger relationship than news. So it starts out lower, goes above. And then that's just your basic, if you get totally lost and you really can't figure any of this out, if you know this, we'll be in good shape. If they cross, there's an interaction. And if they are parallel forever, they are not an interaction. And if you really get lost, you could say that an interaction exists if they cross here or in any plane around it. Let me show you that. So here, in this one right here, remember, I don't even know what number this is. Some of them aren't numbered. Number 7, they don't cross in the plane that we're talking about, but they would cross eventually if you extended those lines. Same with this one. These guys would never cross. These would never cross. They're the same line, and both of these are the same line. We went over that one. Okay, so when we talk about the F, again, there's 3 different levels. Where's my F table? So there's 3 different levels. We look at level A, level B, and then the interaction of A and B. And a separate F test is conducted for each. And the results are completely independent of one another. So you can have the factors the factors could be insignificant, you might not find significance, but the F for the interaction could be significant. Again, this is one thing that I did want to show you with these lines here. This is considered to be no effect either. I think I threw that in there. We already went over this. This is something similar to this table that I gave you. Okay, let's get into it. Just like our ANOVA table and every other test that we've done since the t-test, we have H sub O's and H sub A's. Now, I write them in my examples slightly different than this, but if you get close to this, I'll be really excited. The big thing is with H sub O and H sub A, you're now going to have 3 of them. You're going to have one for the main effects, one for each of the main effects, and then one for the interaction. We'll get to the interaction in a minute. This says that the mean of A1 is equal to the mean of A2. A1 and A2 refer to cells. H sub 1 says there is a difference. So these are equal. You can even put a little 0 here. There's no difference. H sub 1, mu sub A1 is equal to mu sub A2. So that, just so you know where they come from, that would be the mean of A1 and the mean of A2. This is the main effect of A. Is there a difference between getting one pill or getting 2 pills? That's what that does. And then we go back down, and here we are. H sub O, I write it H sub OB, but mu B1 equals mu of B2. H sub 1, the B's are not equal. Let's go back. This is our factor B. This is saying 10-year-olds are different than 20-year-olds. So you can see right there the power, one of the big power, not power, but one of the advantages of a two-way ANOVA, a factorial ANOVA, is that you can do a study and get a lot of information out of it. So you can do a study and find out how pills work and how age works. And then you also get the benefit of the interaction between the two. So that was the B. So we've done A and B. And then the mean difference between the individual treatment conditions. So now we're talking about the interactions. H sub O for interactions is simple. There is no interaction. And H sub 1 is there is an interaction. Super simple. Now, your degrees of freedom, these are going to match what I have here. So this is, remember, well, I shouldn't say remember. They always start off with something different. So books tend to start off with degrees of freedom total. So this matches up with degrees of freedom total. So I have degrees of freedom total written as big N, how many subjects are in your study, minus 1. Or the number of levels of A times the number of levels of B times the number of in each cell, minus 1. Then you have degrees of freedom within treatment. Between treatment, A, B, C. Yep. So this is your error term. Within is always your error term. Degrees of freedom A is number of rows minus 1. Degrees of freedom B, number of columns minus 1. And degrees of freedom for the error term is degrees of freedom within minus degrees of freedom between subjects. Okay, that is another slide on assumptions. I think I just said a couple things differently there. We do have effect size for ANOVA. We compare it the same exact way we compared last week's ANOVA. So it's the sum of squares between groups for the effect over the sum of squares total. We will not be computing it. We will just be getting it from the SPSS printout. And then I put this here, but we are actually not going to be doing it. If you have, let me go back up. If you have a 3-level of an ANOVA, so if you have 1 pill, 2 pill, let's just say you have 3 pill, you can do a Tukey. Because remember, that would give you, and we're not going to do an example of that. I'm stopping at 2. I'm stopping at the 2x2s. But if you have 3 levels of a variable, so if you had 3 of A's and 3 of B, you would want to know, well, which levels of A are different? Which levels of B are different from one another? And then you could do Tukey like we did last week. But we're not going to do that. Okay, so that's the overview. Remember, this is like, we're doing like the 50,000 foot view on this one because it gets really, really involved. So Going down, those are your interactions. Those are more examples of interactions. And now, I don't know where I left this one. Hold on. Slides. There's a sheet. Class notes 2, maybe? Oh, I put the link. Hold on. Sorry. Let me fix this right now. So chapter 13, is this what I want? Anyone done? I'm going to drop it in chat to everybody so you can start opening it if you want to. And then I'm just going to run into here and update it so that it's just done. Edit. Paste. Okay, I had the slides in twice. Class notes 2. Yep. Okay, so we're good. So we have 2 documents that we're going to be looking at. We're going to keep open this one. In fact, I'm going to move it there. And then this is the standard steps of hypothesis testing that we work through. So the first thing that I just want to show you is that these are the steps for SPSS. So if you are having problems with SPSS, just like every other test that we have done, I walk out and I'm going to open up my SPSS real quick so that I can walk you through these steps with the first example, because there is something that's a little different than the rest of them. We'll go over that in a minute. Never gotten that one before. Cancel. Okay. Gender. Okay. So these are the steps. I'm taking Tukey out. I'm going to change this to the right word, which is tough. Look at the cells. So our big thing is to always look at descriptive statistics for the cells. Break. Okay, so our first example is a school example. A superintendent of schools wishes to investigate students' attitudes towards drug use in 2 junior high schools in his district. So we are comparing school A with school B. And we are comparing, is there a difference with gender, boys and girls? 6 boys and 6 girls are selected at random from each school, and they are given the DAAI, which is the Drug Attitude Assessment Inventory, and their scores are recorded. A high score implies a liberal attitude towards drug use. Okay, so this is the way the data is presented to you. It looks just like this data. So we have 4 cells that we're dealing with. We want to know, is there an attitude difference between the 2 schools? So is school A different than school B? Is there a gender difference in attitudes? So do boys think differently about drug use than girls? And then is there an interaction? How does gender impact your outlook on school, or from the school that you're based out of, on drug use? And we're going to test each one at 0.05. So let me bring this over here and this over here. Okay. Oh, you know me, I have way too much open. Get rid of that, get rid of the room. Okay. So this is how you enter your data into SPSS. Can you guys see? Nope. Shoot. Maybe no. Okay. Okay, there it is. So can you see school, gender, and DAAI over here? Yes? And then you can see the data as it's laid out here. Okay, so you're handed this data, right? This is how you lay it out in SPSS. Now, if you've been following along with SPSS, you'll sort of get this right away. But when I was entering and preparing for class, I messed this up because I didn't have the right number of subjects. So that's why I give you the examples, so then you can run these before running your homework. You have 2 schools and you have 2 genders. And then you have scores. So I assigned school A 1 and school B is a 2. Boys is a 1 and girls is a 2. So when you enter this cell right here, these are boys that go to school A. So boys that go to school A get a 1 for school and a 1 for gender. And there are 1, 2, 3, 4, 5, 6 of those. 6 of those. Now, if you get lost, actually, you should take a screenshot of this because I can add it right into the notes for you. Edit, copy. Yeah, I'll add it right here. So that's how you enter it in. Now, if you get lost, just remember, you can look and say, oh, 9, 16, 14, 11, 12, and 8, where are they? They're all in one group. She probably entered them all the same way. Same with B. So you can see that I moved, which way did I move? I moved this way, I think. 15, yep. So then I entered 15, 13, 9, 9, 8, and 11. Those are all school 2 gender boys. Does everyone see how this is working? I know it makes a lot of sense now when I'm going over it. And then I move down to the girls. Girls are there's 2 schools for girls, but now everybody has the same gender. And I entered their score here. Okay. So go through that. Now you have a copy of how that's supposed to look. Now, let's go through and I'll show you how to do this. There's a lot of little pieces to running the SPSS. All of the notes for it, though, they're all written right here. Okay, it is analyze. We're going to a new space now. General linear model. Oops, univariate. Our dependent variable in this case is the DAAI score. How do they feel about drug use? And then you move your 2 independent variables to your fixed factors box. Model, always get the full factorial for right now. Always make sure that the sum of squares is type 3. That's pretty important. Hit OK. We're not doing anything in contrasts. Plots. You enter school and gender, and then you click add, and it'll give you the school and gender plots. You can also do plots of separate ones if you want to, but we don't need to. Make sure that they are line charts. Versus 0, include reference for the grand mean, don't need that. Post hoc tests, we're not going to do because we only have 2 groups. We're not going to save anything. Options, we love options. Get your descriptive statistics, your estimates, your homogeneity of tests. Do not do this one. I know you may be tempted. Do not click this F test. That is not what you think it is. Click OK. Bootstrap we do not need, and we hit OK. Mine pops up in my other screen. Let me grab it and move it over. So what do we got? These are, let's see, it tells us here first, all the N's. How many subjects are in school by school and how many are in each gender? So this is good. We've got all even numbers. If you wind up with a weird number here, you've done something wrong. Well, for this example. Then our descriptive statistics, this is telling you all of the cell means. If we laid these out by cell and by row and by column, we could look at it that way. This is your test for homogeneity of variance, which we will go over. Remember, homogeneity of variance test, write this down if you're still unsure about it. You always want to fail to reject your homogeneity of variance test, and you want a very high significance level. Remember, this significance level is your p-value. You want a high p-value. You do not want to fail to reject. I'm sorry, you want to fail to reject here. You do not want to reject here. Now this mishmash, this is how SPSS gives you your ANOVA table. It doesn't make it easy. You really need to figure out and learn how to find everything. So for this example, I have done just that for you. So let me bring this one over. Nope, that's not the right one. I think it's hiding right here. Yeah, it's my writing. Okay. So let's take one step back first before we move forward. So for this example, yep, okay. I have written out, this is chapter 13, factorial ANOVA, the DAAI example. So when you're losing your mind later, you print out everything that I've left you and you'll see, oh, this is the DAAI scores. We have two factors, two effects, and an interaction. These will match up to what we just learned in lecture. So your H sub O for A factor is no gender difference. Males and females are going to be the same. H sub 1 is H sub O is false. H sub O sub B is the levels of school. There's no school difference. H sub O sub A is that there is. H sub A, here we're saying H sub O sub B is false. And then there's an interaction piece. So this whole big thing means all the cells are equal. All the cell means are going to be equal. There's no interaction. H sub 1 of the interaction is that H sub O of the interaction is false. But write in your notes, A sub B 1 1, alpha sub B 1 2, A sub B 2 1, and A sub B 2 2. Those are all cell means. Phew, that was a lot. So alpha equals 0.05, that's the easy part. And then F critical, where do we get this number from? The table. Got to keep your wits about you here. Our degrees of freedom for our critical value of F from the table is 1 and 20. It's what we're comparing and the error rate. So our critical value of F is 4.35, and we run our study. Okay, so now this F table looks really neat, right? This is not what came out of SPSS for us. I left you guys what came out of SPSS. Oh, wait, let me do this. Maybe this will make it easier. So SPSS prints out a lot of junk that you need to sift through. So you need to make sure that you know where to find everything in the SPSS table. And you'll notice that it looks crazy. You are interested in your two factors, your gender and your school factor. And then your interaction is school times gender. Then you're also interested in the error term and your corrected total line, but the total really doesn't make a difference, so don't worry about it. Now you read across in the table And these are your 3 F values right here. And you can see I've pulled them out and I wrote them very nicely for you in our F table. 15.32, 0.65, 0.656, and 2.204. And then I don't want to go on to that yet. And then this partial eta square, these are the 3 values of eta square, or your effect size. So big effect size, tiny effect size, medium effect size. Let's see, what else we got? And then we have the graph. So we know that there's something going on between these 2 variables. The lines aren't straight. But the question is this interaction, this difference between schools and gender, is it big enough? So let's find out. So what we do is we compare our critical value of F, which is 4.35, to the calculated values from SPSS. And we find out that the only one that is significant is gender. There is a difference between males and females in the way that they look at drug use. Let me see if I left that for you. Where am I in this? Well, that's my output. Okay, so we reject one of them. Remember, there's when you have a 2x2, when you have a factorial analysis, an ANOVA, you have 3 tests that you must talk about. Level A, is there a difference between the schools? Level B, is there a difference between the gender? And then how are those 2 working together? And is it significant? Remember, means don't tell us anything. We need to find out, is it statistically significantly different? So here we're going to reject just the first one. This is the only F that is significant. We're going to fail to reject that there is a difference in school. Yeah, in school and in the interaction. So we say there is a difference on gender. Girls have more liberal attitudes than boys on drug use. And then this is the APA style. There is a significant main effect on gender. This is exactly how you say it. Significant main effect on whatever it is, the context. You know how much I always talk and love context. This is the F that we found, and P is less than 0.001. I don't think I talked about the P, so let's go back. This is the F test on gender. P is less than 0.001, so that's significant. P on school is not significant. P on interaction is not significant. We'll get to those in a minute. There was not a significant main effect on school. F with 1 in 20 degrees of freedom equals 0.656. P equaled 0.428, right from the table. There is not a significant interaction between gender and school. F 1 in 20 equals 2.204. P equals 0.153. All of that gets backed up by the ANOVA table. Questions? No? Nothing? Okay, we'll move on. So I left another example for you. Okay, pull up, I'm just going to zero out my SPSS. I am going to make sure that I bring up the second training and sleep recall. So this is the bigger version of the example that we did on sleep and memory recall from earlier on in lecture. So now I've messed this document up because I added to it. So and I didn't even finish the context. Memory training is impacted. This is wrong. If word recall is impacted by memory training and level of sleep. Sorry about that. Word recall by and level of sleep. Okay, so you have, and let me just put this in its own page. Page break. Okay, so here again, 2 by 2. The internal numbers are number of words an individual recalled. So they somehow put them in the conditions of no sleep and full sleep, memory training and no memory training. Question, is there a difference in memory training and no memory training? Is there a difference in recall based on sleep? And is there an interaction between memory training and sleep? So let's take a look at the SPSS. Let's see. Here we go. Oh, and there's one other thing I wanted to show you, just as a reminder. It can be a really good idea to go into, so I'm in data view where I enter my data, and then you click on variable view, and you can go into these values and label them. We've been doing that all semester, but I just wanted to remind you of it so that, because it really makes your printouts much easier to read if these are all very clearly labeled. So value 1 is memory training, value 2 is no memory training, so you can kind of keep your wits about you there. Same with, oops, okay, and then full sleep and no sleep. And then your printouts come with, they come out a little prettier. Okay, so analyze. Remember, general linear model. We have been hanging out here all freaking semester. We are now graduating to general linear model, univariate. Our dependent variable is recall, the number of words that were recalled. And our 2 fixed variables are, our 2 fixed factors are memory and sleep. Our model, full factorial, type 3. We don't need contrasts. Plots. We want our plots. So you add 1 to the horizontal axis, you add 1 to the separate lines axis, whatever you want them on. You can reverse these at some point if you want as well. And it will give you then a line showing if they're parallel or if they cross. Line graph, don't want error bars, we're good there. We're not doing post hoc. Options. We want descriptive statistics, estimates of effect size, and homogeneity of homogeneity tests. And we want to click continue and hit OK. Okay, so first thing we look at, well, besides the fact that we have the right number of subjects, and we have 7 in each cell. So that gives us 28 total. Our homogeneity test, we would fail to reject. These are all not significant. That means that all of our variance within each cell they're all equal. So that's fantastic. Down, this is our F table. We'll go over that in a minute. And this is our plot. So there is an interaction going on here. There's something going on. We just need to figure out what it is, and if it is significant. Yep, that's the end of that one. Can add this to the top over here, and here we go. That was the rest. Okay, so just like the other one we did, we have 3 different H sub A's and 3 different H sub O's and 3 different H sub A's. H sub O is always saying that there's no difference, and H sub A is always saying that there is a difference. Based on your research, you may want a difference, you may not. But so H sub O of A, your A factor, there's no sleep difference on word recall. H sub B, your memory difference, no memory difference, memory training on recall. And then your interaction, there's no interaction. Alpha is 0.05. Your F has 1 and 24 degrees of freedom. And that critical value of F, remember, anytime you see the star, that's your critical value of F, is 4.26. We decide all this before we run our study, and now we run our study. Let's see, all 3 of these values, I did not write out the whole table for you. Each of these values was picked up right from the F table. Right here. Memory, sleep, and your interaction. Your Fs are located right here. So you have 3 significance. So we know that there is a difference in sleep based on how much sleep you get. There is a difference if you have memory training, and there is a significant interaction. So we reject H sub O, H sub A, and the interaction. And this is how you write out the APA. So there is a significant interaction. There's a main effect on sleep with F with 1 and 23 degrees of freedom equals 50.532. P-value is less than 0.01. Let me just show you where we got that from. Fs are here in the significance column, just like they were in the last example. Okay. Let's see, what else was there to do here? Sleep, that's it. Okay, what are your questions? Anything for me here? We've gone over the slides and then two full examples of a two-way ANOVA, your homework from the book, as well as an SPSS example awaits you. I am now going to go back through to chapter 9 and look at the SPSS answers for your homework. So a researcher, this was the smoking cigarettes. Does smoking cigarettes decrease your sense of smell? So we had mu equals 18. Now, I will tell you that I'm going to give you all the tricks here in looking at printouts. So you know that they are comparing, remember, this is a one sample t-test. That's what chapter 9 was all about. One sample t-test. So we had 12 subjects. SPSS computed the mean for us. We compared it to a test value of 18.4. If you remember, well, and if you do not, make sure to put in your notes that you must tell SPSS what your test value is. And it's sitting right there. If you test it against 0, you'll get a lot of significance, but it won't tell you anything. So this is our calculated value of T. Again, one sample t-test, one row of scores. That's it. One sample t-test. So our calculated value of T is negative 3.417. This is significant. One-sided and two-sided. Didn't matter how we ran it. Know the difference. And it's going to be significant at 0.01 or 0.05. Here is your Cohen's D. It's negative 0.986. We take the absolute value of this. This is very significant. So we would say here that smoking definitely decreases your sense of smell. And remember, we're now out of F and we're back to our T tables. So when you look up in the T table, there's just one number that's your degrees of freedom. In this case, it's n-1. We compare. Now, you don't have to do this part. You can just compare it to the p-value. So T with 11 degrees of freedom. Compare it. You can go up to your p-value. Again, we already went through that. And you reject. Smoking decreases a person's sense of smell. You can then you can also calculate a confidence interval. The effect size is given to you, and I explained here how to look at p-value, what it actually means. And smoking significantly reduced olfactory sensitivity. You list your mean, your standard deviation, and your p-value there. As for a one sample t-test. Seems so simple now that we've moved on so quickly. Let's see, that's 9. And we'll do 10 and 11. Okay. So this is 10 SPSS. Oh. Oh no. Well, I can get my printout. Hold on. No. I hope I can get a printout. Oh, I can. Yay. Okay. Saved by always saving your work. This is a 2-sample t-test, right? Independent, analyze, compare means, independent sample t-test. We have a grouping score. Then we have a regular score. We have options. Always love to look in the options. We have to define our groups, which is sort of ridiculous because it does it for you automatically, but it likes you to click in there. Back. And then you just hit go. Okay. So for this one, which one was this? Oh, wait, there it is. Duh. Sorry, I'm looking at the wrong one. Okay, so this is the first part of chapter 10, homework 2-sample independent t-test. Your t here is 4. Whether you tested this at 0.01 or 0.05, whether you did a one-sided t-test for this or a 2, you were significant because your p is less than 0.01. Your point estimate, this is your Cohen's d, this is humongous. Again, these are weird examples because they're just small for academic purposes. And that is all that's required of the printout part. So here it is. So this is 2-sample independent. So one group has nothing to do with the other. Mu sub 1 equals mu sub 2. I did this at 0.01. At H sub A, mu sub 1 does not equal mu sub 2. We have 18 degrees of freedom. T critical, this is from the book, plus or minus 2.878. It's a 2-tailed test. There is evidence that those who, oh, this was the Sesame Street example. I love Sesame Street. I still love Sesame Street. That those that watched Sesame Street had different or higher level grades than those who did not. Effect size, again, large effect size. We calculated a confidence interval. Where's that? Oh, it's over here. Okay. And then the p-value, I explained the p-value to you, APA. So this is how we, oh yeah, I do remember what, I should have just gotten another piece of paper to write out the APA value, but instead I went right up the sides of the paper. I was laughing at myself. I'm like, I would hate if a student did this. And here I did it to you guys. So those who watched Sesame Street, the mean produced higher high school grades than those who did not. Those who did not, this is their mean and standard deviation, and the t and the p-value. And then this next one was the second on that. Here we had a food waste example. We had 2 groups. Those are their means. Let's see if I can enlarge this. So here our T, it looks like is 2.245 with 14 degrees of freedom. And here depending on how we ran the test, we might have rejected this. So this was a two-tail test. So we rejected. It was based on a critical value. Oops, now it's too big. Okay, our T calculated was 2.245. We just squeaked in at 2.145 with our critical value, just on the other side of it. There is a significant difference between the group that received paper and the group that received plastic and how much food they wasted. Our effect size, again, right from the printout, 1.7, 1.122. And then here's your confidence interval, which you won't have to compute for the final or for the third exam. And then here's how you write out your final results. So the paper plate group wasted more food, mean, standard deviation, than the group on plastic, mean and standard deviation, and then your T statistic, number of degrees of freedom, 2.245, and your P of 0.041. And again, you can see your P right in the printout. It's really small, but it's right here. So your printout should look like that. Questions, 2 sample t-tests? None? Okay, let's go through. Did I separate those out? 12 was ANOVA. Chapter 11. This is a paired sample t-test. Let me see. And this is blurry too. Shoot. This was a funny one though. Let me just pull it up. I can pull up the data. Let's see. I don't remember if this is the right one. Let me run it and I'll let you know. T of 2.3. Yeah, this isn't the right data. Okay, well, unfortunately, I'll have to get you a clear. I will make sure that I get a clearer before, after. Yeah, I have the wrong data here. So I'll get you a clearer version of this so that you have it for your notes. But here, if you looked at the critical value of T from the book, or if you looked at the calculated value of T, which was -3, calculated beats, fails to beat the critical value, so you fail to reject. And then this is really a train wreck, this one, because I did not include, there was a second piece of paper with 6, which is write out your results, and then 7, which was APA style. So I don't know why 1 was so blurry and 3 is missing, but I will get those to you guys. So chapter 11, SPSS, 1 blurry, and 3 SPS, APA style. Okay, so that was a little review. Those are the kind of the things that you should be able to do. Again, we have homework regular due next week. We'll go over regression. There is a lot of regression. There's a lot in correlation and regression that we need to get through. So it is jam-packed. We will definitely go the full 2 hours next week. The following week is chi-square, when your review packet / exam 3 drops. And then we go right in and march towards the final. So if you guys have any questions at all, you let you guys know where to find me. People have been making appointments. We've been going over all of this. No big deal at all. I'm always here for you. And let me know. That's about it. So I'll see you next week if I don't hear from you before then. Oh, I can stop the recording now.